Hello everyone, welcome back to my channel. This is the third video of the series Ease into Coding along with Complexities. So if you must have not checked my previous videos of this series, I'll be providing the links in the eye icon above so you can access them from there. Also, if you have not subscribed to my channel yet, do subscribe by clicking on the subscribe button and also hit the bell icon to never miss an update. Now, since this is the third video of this series, we are moving quite ahead and we'll be taking up questions which is somewhat more hard than the ones we encountered before. So as you can see, this question over here is of medium level, but to bring to your notice, this question was asked in several interviews, in one of the Amazon interviews, in one of the Facebook interviews, technical interviews, and does come in one of the most asked questions in any company's technical interviews, and also is one of the most tough questions that any student has faced in their technical interviews. So I would request all of you to pay extra attention to this question, because in this question I would be solving this question using three approaches. The first one would be, of course, the brute force approach. The second one will be the sliding window technique, and of course the last one will be my approach in order to get the complexity even more less. So let's begin with this. So I've again taken up a question again from LeetCode, and I'll be pasting this link of this problem in the description below. You can access this question from there. Coming back to this question, if you must have gone through this question, in this question we are given with the following string. As you can see in example 1, we are given with a string, and what we need to return is the longest substring without repeating characters, exactly the heading. That is, in this question, if you see in this example, if you see, that is ABC is definitely going to be the longest string until A again is encountered, which will be a repetition of the previously encountered A. So we need to find the longest string in order that there is no repeated characters in that string. Looking at example 2, we have B, which is repeated, the character B which is repeated, but here you see that the frequency is 1. That means B keeps on repeating, hence we just need to return 1, because the longest substring that doesn't have any repeating character is B. Also, coming to the third example, we are given with the string again, and in this string it's very clear that the answer that we would be returning is WKE, because that is the longest substring that is present in this given input string, and we need to just have the int value, not the substring. So yeah, that is the return type of this function. So definitely when any one of you encounters such a question, the first approach that comes in mind is the brute force approach, because this is the most common approach, and let's begin with that here as well. So as you can see that when I implemented this code using brute force, what I'm going to do over here is, if we are given with the same, I've just copied the first example over here, the same input example that we are given in the question, that is over the example 1, I've copied in the editor, in my editor. And what we are going to do first over here is, so here what we are going to do is, we'll be the first loop will be basically for iterating throughout the entire string, that is from I equals to 0 to I less than string dot length minus 1, and for each iteration we will be initializing the value of length to 1. And then after that, let me just change the color of the pen, because as requested by most of you, because it is you get the strain to your eye. So now carrying on forward, when we run the next loop, that is from j equals to I plus 1 to less than string dot length, that is basically to give you an illustration. I is pointing to the first character, and j will be pointing to the from the second character till the last character. So what we are basically checking in this brute force technique is, let's not come to the if parts because most of you will get confused. Directly let us come to what will happen each time. We are going to do a length plus plus, that is if the second character that is over here, that is s of j b, that doesn't match s of I, that is it doesn't match a, so this if condition won't work and we'll directly come to the length plus plus. Initially the reason I have made length equals to 1 is because we are directly starting comparing with the second character, whichever is I plus 1. So already, as you can see, we have covered one character in a substring, and that's the reason I've initialized it to 1 and not 0. As soon as we encounter b, we are going to as it is not equal, this if will not work, and we are going to do a length plus plus. Now our length, the variable length will hold a value of 2. When we come to c, then when our j gets incremented and moves to c, again we move forward, and the same thing, the if won't work, and we'll directly come to length plus plus, which will make our length variable 3. After that, what we'll be doing is, as soon as we come to a, which is the first repeated character, we will check that yes, s of I is equals to s of j. That means we got a repetition for the string. That means we need to first store the value of the previous length that we got in order to store it somewhere, and then compare with all these lengths that we'll encounter later on, and then check whichever is the maximum one from them, we'll be returning that. So what we'll be doing, as soon as we encountered a repeated string, we will enter this if condition, and inside the variable m, which was previously initialized to 0, we'll be storing the max out of this m itself and the variable length that we have already calculated. So the value of length is 3. As you can see over here, the value of length is 3. So for sure the m is going to hold a value of 3, and we will break from this loop, because as soon as we encountered a repeated, we are not moving forward. Now what we are going to do is, the same thing is going to carry on from b. That means now I will be shifted to b, and as you must have guessed already, if I is pointing to b, j will run from c till the end of the string, and similarly I will then point to c, then to a, and then to b until the last but one element. As you can see, length was length minus 1, because j is going to start comparing from I plus 1 index, and that's the reason we are just going up till the last but one element. And by doing that, it's quite obvious that each time we encounter a repeated string, if condition is going to work, and then we are going to check whether our length has a new value which is greater than the previously calculated maximum value. Here basically our m variable is going to store the maximum length of the string substring, which is asked by this function. And once this is calculated, we come out of both the for loops and we return this variable in order to get the length of the longest substring without any repeated character. But let me just go back to the editor and run this code. As you can see, this is the same code. I'll be quickly, as you can see, I have already run this code before this, and we got the right outputs. But I am quickly submitting the code, and in order to just show you what we'll be getting as the output after running this code. And as you can see, we got a TLE, that is the time limit exceeded error. And this was quite obvious because a question that is asked in Amazon and Flipkart, Amazon and Facebook interviews are definitely not going to be the ones which will run so fast and just with the brute force approach. So in order to pass this question, we need to use some optimal approaches. So the second approach that I will be discussing is the sliding window approach. And for those who don't know what a sliding window approach is, or the sliding window technique is, usually in such techniques, when we are given with a set of input values, we would be using a sliding window, basically, which will be accessing a certain set of elements, and that window is going to slide through the entire set of the group of elements, and that's how we access all the elements in order to arrive in an optimal solution. So how are we going to use the sliding window technique over in this question? We are trying to bring a complexity down, that is the previous complexity that we had over here was almost, was definitely not definitely of the order, yes, it was of the order n and n, that is n square, which was not optimal, and because of that usually brute force techniques end up having such long complexities, and that's the reason we couldn't arrive to an optimal solution. So we would try to make our code quite optimal in order to pass the test cases. So the first thing we will be doing over here is define a variable for the left hand and the right hand of the window. That means, as you can see over here, we have the window, so it is definitely going to have a left and the right hand. So let us denote the left hand by variable I and the right hand by variable j. Then we are also going to initialize a variable m set to 0, which will be the value that is going to be returned, that is the length of the largest substring. M will basically hold the maximum values out of all the substring lengths that we have encountered. Before that, we have declared a set of cat data type, and the name of the set is S1. Basically, what a set is basically a container which has all its elements unique and also in a sorted order. So we declared a set in order to the basic functionality of set over here. To give you a rough idea, the basic functionality that the set would be performing is, as you know, that set has only unique elements. So if we inserted a, then we are going to check for we are going to iterate through the remaining elements, and we are going to check for the next iteration of a repeated element. In this case, let's check if a is again repeated. As soon as a is repeated, and if you try to insert a again, then of course the insert function is going to return a false value if a already exists. That means in a set, when you try to insert element that is already existing, the insert function returns a false value. The insert function doesn't completely return a false value. And to give a brief idea for those who are really interested in that, is the insert function basically returns a pair over here, and the pair has two elements. The first element is going to be an iterator, which will be pointing to the newly inserted element or the equivalent element. That means what it does is, the iterator, if this is a, that is a new element, just think this was a new element that was inserted. So there will be an iterator pointing to this itself, or if there was an a which was already present in the array, and again if you try to add an array, the iterator will still point at that element, but that will not serve the purpose what we are going to do. So what we are going to check is, and what actually matters for us, is the second element, the one that is highlighted over the pair second, that is the second element of this return, is an element which returns true or false. True if the new element was inserted, and false if there was an equivalent element already present in the set. So that will serve our purpose, and that's the reason we have used dot second over here, which we'll encounter in a while. That means when we try to insert an a again, if an a already is present, then we will result into the insert function will return false, and that's somewhere when we can implement our code in an other way. So coming back to the implementation part, what we are going to check is, the first thing we are going to run our loop, that is the right end, until end of the string. That means our right end will go up till s dot length minus 1. Then what we are going to check is, we are going to try to insert the element, that is s1 dot insert s of j. We are going to try to insert, let's come over here, since our I and j are 0 right now, even our I is over here, and let me denote j by a green vector. So I is also over here and j is also over here, and what we are going to try is, we are going to try to insert the element s of j inside the set. And as all of you know, here the set is not going to is not having any a before, and a successfully will be inserted in this set, and dot second is going to return a true value. Because of this if condition will have a true value, and the if part will get executed. And do remember, if we get a false value, then later on we'll come to the else part. So what our if part is going to do, first we are going to do a j plus plus. That means now j will no longer point over here, rather it will point to b. That means our j is right now pointing over here. And then what we are going to do is, we are going to return the max out of the original m. That is, as I told before, this m is going to hold the length of the longest substring that is to be returned, and at each iteration we are going to even calculate the length of the initial substrings that we get without any repeated character. And as you can see, j minus I will serve the purpose, because here j is b and I is a, so j minus I is basically 1. So max out of initial value of m was 0 itself, so 0 and 1 will return in 1, and now currently our m is holding the value of 1. As soon as we go to the next iteration, that is now since after the previous j plus plus, our b was pointing at j, j was pointing at b. Because of that, now we try to insert b inside this, and as you all know, again there was no b, so b will successfully be entered. And similar case, and the if will work, and the same thing will happen for c again. And since there is no c, c will again get inserted, and again there will be a j plus plus. How it reads c, because of course during b there was again a j plus plus, and now finally this was something we had. And because of that, what our max got changed when it was at b, our max became 2, because 0 1 and 2, the greater was 2, and again right now 2 and 3, the greater is 3. And because of that, the value m will be holding is 3, because till now it encountered these 3 variables, and j minus I which was previously at 0, I which was at 0, and j right now after the the iteration that c had is right now pointing at a. After this is the main area of concern for us right now. As soon as we encountered an a which is getting which is the repeating character, and since we got a repeating character over here, our else part is going to be executed. Let's see what is in the else part. In the else part, we are going to erase whatever was there at the ith index. And what do we have at the ith index? The thing that we have at the ith index is a. So this a will be erased. So now our set doesn't have a. After that, we are going to do a I plus plus. That means now our I is going to point at b. And after that, yes, j will again no, there is no increment to j, so j will remain same. So j will remain same. And now what our code will try to do is, since j is pointing at the same thing, it will again enter this while condition, and now our if will work. That means we'll try to insert the a again, and since we had in the previous iteration we had removed this a, now the set doesn't have one more a, and a will again be successfully entered in our set, and which will result in a true value, because of which our j will now point to the next element. And now we need to find the max out of m and j minus 1, which means j is right now over here, that is 0, 1, 2, 3, and 4, and our I is currently at 1, as you can see. So 4 minus 1 will result in 3 again, and I think the previous value also the m was holding was 3, so nothing is going to get altered. And the same thing, as you can see, the pattern is being followed when it comes to C. Again the first, this when it comes to this one, that is B, B will first be removed, this B will get added, and when it comes to C, this C will be removed and this C will be added, and again that pattern continues. But as you can see later on, when we come over here, there will come a case when we have this C and B, but still that is the length of that will be 2, and the initial m value that we have is 3, so 3 is greater than 2, and because of that the max function will will neutralize everything, and when b is encountered, everything again gets distorted, because a repeated character is encountered. And that's something, that's a clear concept understanding that I've given over here, and hence m will hold the maximum length of the longest substring without a repeated character, and that will be returned by this function. This was the code which I implemented after having a brief lookout over the web. But what I got to know in this question is, when usually you calculate a complexity for a question by considering the worst case that the question can go through, and if you look in this question, the worst case this question can ever go into is when you don't encounter a j++. That means since your loop variable is j, that means you're initially checking that your j should reach the end of the string, but your j++ is inside the if condition. That means if there is any input set which runs else for each if condition, that would result into a complexity almost equal to the one that we encountered in brute force, but slightly optimal than that. And to look how optimal it is, let us quickly run this code in order to check how optimal this solution can be, which is the one that the web, and try to implement it in my method using the sliding window technique. And as you can see, it took about 108 milliseconds, which is just faster than 50.02% of the C++ submissions. But at least we are satisfied that our code was able to run within the given time limits, and we didn't again face the time limit error. Now finally coming to the main and the most important part, and the bonus that I would be giving, that is my approach. And to reveal even more further, my approach by far has worked better than both of these cases. So quickly brushing upon my approach, which is almost similar to the window technique, the sliding window technique, you can just relate that, but the thing that I've done different, even that would be quite clear over here. So again, I've declared a set, and here I have declared one extra variable, that is length, which will because in the previous case, as you must have seen, that here we were doing j minus 1 in order to calculate the length of the substring that we encountered in each in each iteration, but here we'll not be doing that. Rather we will be storing it in the variable len, and that's the reason I've initialized that to 0, and the remaining m equals to 0 is the maximum length of the substring, and we have I equals to 0 and j equals to 0, but the only difference over here is my I equals to 0 is going to act as the right end, and my j equals to 0 is going to act as the left end over here. So what I'm going to check is my right end goes up till the end of the string as usual, and the only difference over here is what I'm going to do is and one more thing if you must be noticing is I have done the insert in the else part, and the erase in the if part. That's just a switch of the conditions that these both approaches have used, but the main area of concern is the thing that I have done over in the while loop over here. This while loop is not going to take up more the more running time, because it's just running up till a constant time. Because what just coming back to the previous problem, previous illustration, what I'll be doing over in this case is that we are going to we are going to increment our j variable until and unless the element at that index becomes equals to the element at the index I. To give you a quick overview about what exactly would be happening over this, let me just quickly start with the explanation part for this code in order to make you all understand that what this will result into. As you can see, where we were going, I was going up till the end, and then the new function over here, the function count in set returns only two values: 0 if that element exists, or 1 if that element doesn't exist. That means this if will only work if that element exists in the set. So directly we need to come to the else part, because at the start elements are not going to exist. So s1 dot insert, there'll be an s1 dot insert si. That means since I was pointing over here currently in a set, a will be inserted. After that we are doing a len plus plus, because the initial length of our substring currently is the length, and at the same time we are going to store it under max, under the maximum variable that we had declared with the name m. That means if the previous value of m was 0 and the new value encountered was 1, that means as and when we will get the new values of len, at the same time we are going to check with the previous value of m, and we are going to store it in the final value m again, that is the maximum out of these values. So right now the maximum out of 0 and 1 will be 1, and that's the reason m will hold 1. After that what we'll do is we'll go for b, and b again doesn't exist, and the same thing will work, and b again will be added. The length value will now become 2 because of the len plus plus, and now the initial value of m was 1 because of the previous iteration. The second value is that is the len value is 2, and 1 and 2, that means the value of our m will now become 2. Next we'll go for the next iteration. Now I is because of the I plus plus in the last, now I is pointing at previously it was pointing at b, now it is pointing at c. As soon as it points at c, now again our c will be added, the total length becomes 3, and because of that we come over here, len, and the previous value was 2, so 2 comma 3 will result in 3, so now the value of m will be 3. Quickly erasing this, doing a I plus plus. Now I will be pointing at a. As soon as it points at the first repeated string, that is when what unique my code does is going to be shown over here. As soon as that is encountered, we enter the if condition, and in if condition we are going to check until and unless, first we are going to check is our s of j, because j is 0 and j has not been changed yet. So our j is right now pointing over here and our I is pointing at the other a. We are going to check, are these two equal? So as you can see over here, these two we are going to check not equal case, and here we see that these two things are equal, and because of that our while will not work over here. But what will happen is, in our len, I minus j will be stored, because our I right now over here is 0, 1, 2, 3. So I minus j will be 3 minus 0, that is 3 will be the value of our len, and there will be a j plus plus. That means now our j, which was previously pointing at a, will now point at b because of the j plus plus. This was a clear case, but since we couldn't enter the while condition, let me bring you to that part by looking at the second example that we have over here. Just in case, just ignoring the previous things, as you must have already computed over here, that p will easily enter the set and even w will enter. Until now our len value would be 2, and so would be the value of our m. So now because of that, the value that m would be holding is, so the value that our m would be holding right now is, because of these two, the length is, the maximum length till now would be encountered would be 2. But as soon as a third w is encountered, that means that our I is pointing at this w, and of course j would be pointing at 0 by default. And as soon as when this is encountered and when this if is entered, we are going to check, is this s of j equals to s of I? That means, is this w equals to this p? The reason we are doing that is, first we are going to check what was a match for that, because of which this happened, and we are going to reach till that element, because we are going to only consider elements after that. The reason being, just think, in this case the first element only was going to get returned, but just alternating the similar case, if we had something like a, b, c and again a b, then b would be the one returning. And if we would be checking it with j would not be j would definitely be not equals to, and that's the reason we would be coming up till that element which is the one that is returned. And because of that, until and unless that is not equal, that is while s of j is not equal to s of I, that means till the moment this condition is true, as in here, we are going to erase s of j. That means this element is going to be erased from our set, because we are not going interested in any elements that is before the one that is repeated. That means, if just in this case a, b, c and d as over above, as you can see, we are not interested in this a which comes a and b. Of course we will not be interested in the one that is repeated, but we are also not interested in the one that comes before that. And that's the reason we are going to delete all the elements that comes before that, and we are going to update our value up till it comes to the fresh value which is not yet repeated. And that's the thing we are going to do. We are going to repeat, and we are going to do a j plus plus, and once after coming till that element, that is when our sj becomes equals to si, that means when our sj is pointing at j is pointing at w and I is still pointing at the second w, what finally after calculating the length we are going to do is we are going to do a j plus plus. That means j also will point at the place that I is going to point, and in this case none of our while condition is going to work, because the first element that was encountered, that is only the first element that is going to be deleted from the set. And the reason I consider, and the remaining things are just going to be the same thing. So once if you look onto the code, that things are self-explanatory. The thing that makes this code little optimal than the previous code that was slightly referred over the web is, in the previous code, if you must have looked clearly, we had a j plus plus inside a while condition, and being inside a while condition, that didn't guarantee that our j is just going to have a complexity of n. And but in my my approach, you can see it is going up till s dot length. Inside also we have a while condition, but that while condition is just going to be up till some constant variables, and because of that my code, it is very hard to tell what will be the exact complexity of both these codes, but it is it's somewhat easy to relate the codes and tell that my code will definitely have a better complexity than the one that I had referred over the web, that is the sliding window technique. So just to give you the proof of that, let me just um, comment the previous code and comment this code in order to run this. And yeah, of course this will result in the right solution because I had run this before this, and I'm quickly going to submit in order to see how better it is than the previous code. And as you can see, the runtime is 52 milliseconds. Before this I also, as you can see over here, I also received a 42 milliseconds, which was greater than around many percent of C++ online submissions. So all I can say is that this was one of the codes. As you can see, it is greater than 47.14% of your other C++ submissions. This question came under the category of medium, and is definitely one of the most confusing and one of the most twisted questions. So I even hope that I was able to somewhat explain this question to you guys in a better way, and try to minimize the approaches in order to reach into the most optimal approach. So if you liked my concept and if you like this video, do hit the like button. Also, if you have not, if they are still stuck with this question or are looking for a better approach, and also if you got a more better approach than this but in C++ language itself, do let me know in the comment section below. I'd also encourage the other languages. And that was all with this video. I'll be meeting you in the next video. Till then, bye bye, take care.